Hello. In this work, we present ToolBrain, an open-source reinforcement learning framework for training language-enabled agents. Training agents to reliably use tools is an important step toward more capable AI systems, but it remains a challenging problem. First, many existing frameworks have a high barrier to entry. Second, agents can struggle when faced with a large and diverse set of tools. Third, designing effective reward functions is often slow and difficult. Finally, training such systems typically incurs substantial computational cost. To address these challenges, we introduce the coach-athlete paradigm, an architectural abstraction for structuring the training of tool-using agents. As shown in the architecture diagram, the paradigm cleanly separates responsibilities. At the core is the athlete, which is your own agent, focusing solely on task execution. Surrounding it is the adapter, which observes the athlete's actions and translates them into a standardized execution trace. And finally, the coach, our ToolBrain API, orchestrates the entire learning loop. Here's how it works. The coach issues a command, the athlete executes, and the adapter translates the actions into a trace. The coach then analyzes this trace to learn and improve internally, and applies these updates to the athlete's underlying model, completing the cycle. This separation of concerns makes the training workflow modular and accessible in practice. This architecture supports a streamlined training workflow. First, users can bring their own agent, implemented in an existing framework such as LangChain or small agents. Second, the agent is wrapped by the ToolBrain brain, where the training strategy and optimization objectives are specified. Third, the agent can be initialized through knowledge distillation from a stronger teacher model, providing a useful starting point for learning. Finally, a single training command launches the reinforcement learning pipeline, with the remaining optimization handled automatically by the framework. We now demonstrate how this workflow applies across three representative tasks. First, an email search task that evaluates multi-step reasoning. Second, a finance task focused on quantitative reasoning. And third, a weather API task that illustrates real-world grounding through interaction with an external service. Before training, the agent exhibits unstable behavior. In this log from the email search task, we observe frequent syntax errors and repeated execution patterns, which prevent the agent from completing the task successfully. Similar limitations are observed in the other tasks. The agent struggles with accurate numerical reasoning and does not reliably invoke external APIs when required. After training with ToolBrain, the agent exhibits more consistent behavior. For the email search task, the agent now performs a coherent sequence of actions. It searches for relevant keywords, reads the appropriate email, and synthesizes a response based on the retrieved information. In the finance task, the agent correctly maps natural language queries to the corresponding calculation tools to perform precise computations. Finally, in the API task, the agent interacts with an external service to retrieve live data and generate grounded responses. This transformation is strongly supported by our quantitative results on the main email search task. For the 7B model, the success rate more than triples, increasing from 13% to over 43%. Importantly, the hallucination rate is nearly cut in half, and the agent becomes more efficient, completing tasks in fewer interaction steps. Even the smaller 3B model, starting from essentially zero capability, successfully learns the full multi-step workflow, achieving a success rate of nearly 17%. This demonstrates that ToolBrain is effective across model scales, not just for large models. Furthermore, to demonstrate the flexibility of our framework, we rapidly adapted a compact 0.5B model to two entirely new tasks. Using only knowledge distillation, both the finance and API agents achieved substantial performance improvements. This highlights ToolBrain's efficiency for rapid specialization, even with small models and minimal training overhead. In conclusion, ToolBrain is an open-source framework that enables modular reinforcement learning for training language-enabled, tool-using agents. We invite you to scan the QR code to explore our GitHub repository, where you can find the full source code, our paper, and the complete video demonstrations. Thank you for your attention.